we have the topic is about the particle physics, and in this particle physics what you will learn about the fundamental particles. Fundamental particles, basically these are the particles which cannot be broken down into simplest or the smaller one. We call them as the fundamental particles. Fundamental particles are divided into two classes. Like if you recall, when you start studying physics or chemistry, there you started with the Dalton's atomic theory. Dalton says that everything is made up of a small particle called atom. And he says atoms are indivisible. That the concept at the time of a Dalton. But then we came to know that not only, like he said, the atom is a basic unit is there. Then we discuss about structure of an atom. An atom actually consists of a nucleus, and inside the nucleus we have neutron and protons, and around the nucleus we have shells, Kl, Mn, which you have studied in chemistry. Then these shells are further divided into subshell. You have studied in chemistry like SPDF, and subshells are divided into further orbital, like the place where maximum two electron can adjust. Same thing about the nucleus when we go in detail about the nucleus and these particles. So we found that some of the particles which are inside an atom, like neutron, proton, and electron, some of them are not fundamental. Means we can break them into further. So, what are the fundamental particles? There are two families of the fundamental particles. One is known as a quark family. Another one is known as the lepton family. The quark family, basically, what is a quark family? You have to learn the name of these particles. What are the types of the quarks? We have up, down, top, bottom, charm, strange. These are the names of the particles. Like this is representing the family of the quark, which are up, down, top, bottom, charm, and strange. Like example, yeah, this is very strange that a particle name is strange. So we have different quarks are there, up, down, top, bottom, charm, and strange. And what are the symbols? We use small letters to represent. Up is U, down is D, top is T, bottom B, charm C, and strange is S. Actually, atom consists of particles like neutron, proton, and they are made up of subatomic particle or fundamental particle, which we call quarks. And for every particle, there is an antiparticle. Whenever there is a matter, there is always an antimatter. What is the difference between a particle and antiparticle? The only difference between the particle and antiparticle is the charge, the major difference. That particle and antiparticle carry an opposite charge. Like example, if a particle carry a positive charge, what will the charge on antiparticle? Negative. If a particle carry a negative charge, what will the charge on antiparticle? Positive. So particles and antiparticles are basically a combination that they have the same masses, they move in the same manner or spin, but the only difference is the charge. Now, what is the charge of these particles? What is the charge of up? It is easy to remember. The up, top, and charm represent a positive degrees. So what is the charge of up? The charge of up is plus 2 by 3. 2 by 3 E. Like 2 by 3 times E. What is E? E is the charge of electron, and what is the charge of electron? is representing a charge of electron which is 1.6 into 10 to the power minus 19 coulombs. That is the charge of electron. So what is the charge of up? What does it mean? It means 2 by 3e. Means 2 multiplied by 1.6 into 10 to the power minus 19 divided by 3. So instead of writing this number, what we write? We write e. So the charge of the up is plus 2 by 3. What is the charge of top? It is plus 2 by 3e, a positive degree. What is the charge of a charm? It is also plus 2 by 3. So these are the charges of the positive particles, positive fundamental particle. What about the charge of the negative fundamental particles? The charge of electron, yes, it will be given in the exam. You don't have to memorize the charge. That will be given as a constant. The negative particle have the negative charge, but it is a fraction of charge of electron, which is 1 by 3 times the charge of electron. This is also 1 by 3 times the charge of electron. And this is also 1 by 3 times the charge of electron. So the first family, fundamental particles have two families, like categorized into two. One is called quark, another one is called leptons. A quark family or a lepton. So first we have 6 quarks. What are the quarks? Up, down, top, bottom, charm, strange. And their charges, how to remember the charge? Just remember the positive degrees will have a charge of plus 2 by 3 and negative degrees have a charge of minus 1 by 3. And where we find these quarks, actually the proton is made up of quarks. Like if you remember the proton, what is the charge of a proton? The charge of a proton, we write it is plus 1.6 into 10 to the power minus 19. Plus 1, relative charge is plus 1, but actual charge is what? It is plus 1.6 into 10 to the power minus 19. Actually, the proton is not a fundamental particle. Proton is made up of what? Proton is made up of 3 quarks. What are the 3 quarks the proton is made up of? It is made up of up, and down. And you can see what is the charge of up? What is the charge of up? 2 by 3 E. What is the charge of this another up? Plus 2 by 3. And what is the charge of down? Minus 1 by 3 E. When I simplify, so this will be LCM 1, 2e, like 2e plus 2e minus 1e. So what we'll get? We'll get 3. When I simplify, what I will get? I will get plus e. So actually what is proton? Proton is not a fundamental. The composition of the proton, it's having 2 up and 1 down. And it is made up of quarks. Is it clear? Anyone having a doubt or a question till this point? We can say that the relative charge of up is plus 1 and down is minus 1. No, relative charge, actually, this is a relative charge. Plus 2 by 3e is a comparative charge. Compared to the electron, it has a charge of, the actual magnitude will be what? The actual magnitude will be 2 multiplied by 1.6 into 10 to the power minus 19 divided by 3. That will be the actual magnitude. This, when I wrote plus 2 by 3, is actually it's a charge compared to that of electron. So it is the relative charge. So relative charge of a proton is plus 1 because, or you can also say plus E, and E stands for what? E stands for 1.6 exponent minus 19. The meaning of the E is 1.6 exponent minus 19. Same thing. What about neutron? Neutron is also, it's not a fundamental. What is the neutron? Neutron also consists of the quarks. What is the composition of the neutron? The neutron is made up of what? It is made up of up, down, down. So What is up? Up is plus 2 by 3e. What is down? Minus 1 by 3e. What is down? Minus 1 by 3e. When I simplify this, so this will be 3, and this is what? Because 2 minus 1, so we'll have 0e. So when I simplify, so what is the net charge of the neutron? There is no net charge on the neutron, so neutron does not have any charge. So what neutron is made up of? Neutron is also made up of quarks, which is up, down, down. Is it clear? Anyone having a doubt or a question about the fundamental particles of the quark family? Then these are particles. But if I want to write an antiparticle, what will be the antiparticle? So these are all what quarks. If I make antiquarks, up, what will be the opposite of up? So the particle name is called anti-up. And what will be the charge on the anti-up? Good, that will be minus 2 by 3 E. Then we will have anti-down. What will the charge on anti-down? Plus 1 by 3 E. Because the only difference between a particle and its antiparticle, it will be the charge. Then we will have anti-top. What will be anti-top? So minus 2 by 3. Then we will have anti-bottom plus 1 by 3. Then we'll have anti-charm minus 2 by 3e. And then we will have anti-strange, that is equals to plus 1 by 3e. So we have the fundamental particles, which can be a lepton family or a quark family. A quark family can be a quark or an anti-quark. Okay. So quarks, remember, just for quarks and anti-quarks you can make by yourself. If you remember for quark correctly, antiparticle will be oppositely charged only. That will be the major difference. They are different. Now what about the symbols? How they are different from each other? When you are making for a quark family, so if it is up, how we represent up? U. How we represent anti-up? U bar. How we represent down? D. How we represent anti-down? D bar. Then how we represent top T, anti-top T bar. Bottom B, anti-bottom B bar. Charm C, anti-charm C bar. Strange S, anti-strange will be S bar. Then we move to lepton family. What are the leptons? The leptons are basically electron. So electron is a fundamental particle. Anti-electron or electron neutrino, I mean. Anti was a anti-particle. Tau, tau neutrino. Muon, muon neutrino. So these are the lepton family. It is easy to remember their charges. Electron symbol is E and the charge of electron is also E. Electron neutrino. What is the symbol for electron neutrino? It is, this is a Greek alphabet mu, like we normally use for frequency. So this is a symbol and we write a subscript E. So this will become electron neutrino. Tau, this is a tau, and tau neutrino. Neutrino symbol is like this, but it is a tau neutrino, subscript tau will be there. Mu, this is a symbol mu. And what is the symbol for the muon neutrino? It will be, this symbol is for neutrino and subscript we change according to the particle. And what are the charges? What is the charge of electron? Negative, neutrino 0. Tau negative, neutrino 0. Muon negative, muon neutrino 0. So muon neutrino, tau neutrino, and electron neutrino does not have any charge. And electron, tau, and muon, they have the equal or the same charge. Their relative charge is -1, or you can also say they all have the same charge, which is 1.6 exponent minus 19 Coulomb. Then for every particle, there is an antiparticle we call antilepton. So antilepton, the antiparticle of a proton is called a positron, not antiproton, anti-electron I mean. The antiparticle of electron is called positron. And the symbol for positron, the charge of positron will be plus E. The antiparticle of this one is called anti-electron neutrino. So we just add anti. For rest all of them, we just add anti, like the same way we did there. But only difference that antiparticle of an electron is called positron. Rest all of them remain the same. If you want antiparticle of anything, like if it is up, you say anti-up. If it is down, you say anti-down. But only the antiparticle of the electron is a positron. For second one, anti-electron neutrino will be the antiparticle. Or you can also say positron neutrino. Okay. For electron only, tau, anti-tau. Tau neutrino, anti-tau neutrino. Muon, anti-muon neutrino. So the symbol for the particles, the antiparticle symbols, we just put a bar. Anti-electron neutrino, tau neutrino, anti-tau neutrino, then anti-muon and anti-muon neutrino. So for every particle, there exists an antiparticle, and the only difference between a particle and antiparticle will be the charge. But what is the opposite of zero? It will be zero. So even if it's an anti-electron neutrino or electron neutrino, they both have a charge of 0. So the fundamental particles are only 12 fundamental particles. Like everything, every matter, what you see around you is made up of, it's not like all fundamentals should be there in the same substance. It may have, like electron might be there, up is there. It's not like all the particle in the same substance, but every material or every matter what you see around you is made up of these particles. So when we say hydrogen atom, a hydrogen atom consists of what? Hydrogen atom consists of one proton and one electron. If I say identify the fundamental particles here, so what will the fundamental particle? Electron will be the fundamental, that is one. Proton is not a fundamental. Proton is made up of what? Proton is made up of up and down. So what are the particles? What is the composition or the fundamental composition of hydrogen atom? The hydrogen atom consists of electron, up and down. But when I say what will be the composition of antihydrogen? What will the composition of antihydrogen? Antihydrogen. This is a hydrogen atom. So antihydrogen will have what? It will have positron. It will have anti-up. it will have anti up and it will have anti down. So for every particle, we can have an anti-particle. If you have seen a movie called Star Trek, in a Star Trek, they propel the starships by using a matter and antimatter. Because when matter and antimatter combine with each other, it can produce energy. So the concept what they use is the matter and antimatter fuse with each other, which release an energy and propel the ship, and it produce enormous amount of energy. That is called annihilation, which you will study in A2, not in AS.
It has different things in its electron.
Electron is fundamental. It cannot be broken down. Nucleus having proton and neutron, which we know proton is up, up and down, and neutron is.
For the whole part.
This